Hello, Mr. Melo here, your online math teacher, and welcome to my channel. Today we're going to be talking about making histograms. So continuing my graphing one variable data series of videos. So if you find this video helpful, consider hitting the like button and subscribing, and let's go. So here's the scenario. We want to know what percent of your home state's residents were born outside of the US. And I have this table here that shows this information for every single state. Staring at this table is pretty overwhelming. I'm from Massachusetts, and I can see I'm sitting pretty at 14.1 reasonably fast from this table. But if I want to figure out what percent of states have a higher or lower percentage than Massachusetts, it's going to be pretty hard from this. This table is kind of overwhelming. That's where histograms come in. So we are going to make a histogram. Now, to do that, we are going to make a frequency and a relative frequency table first. So what that means is I'm going to group some of the states together to help make a histogram. Now, how you group is depending on your data. So in this table here, the lowest state is right around 1.2%. And we can find that as West Virginia down at the bottom. The largest is California at 27.2%. So that's how spread out our data is. So what we're going to do with histograms, we group together numbers to make intervals usually. Now, because of how my data is spread out, you can pick wherever you want to start your groupings from, as long as each grouping is the same width. I'm going to start at 0, but I don't have to start at 0 if I didn't want to, and group in 5s. So I'm going to tally up how many states have percentages of people born outside of state or foreigners between 0 and 5, but up to not including 5. Then from 5 up to 10, but not including 10. From 10 up to 15, but not including 15. And so on. So it's important each one of these intervals is with 5. I've kept the same length. Now, I've added a little tally chart here because that'll make it a little bit easier if you're at home trying to count these. So pause this video, see first how many states you find that have percentages from 0 up to 5, but not including 5. Okay, hopefully you pause it in the video and try this, and you identified, hopefully, that there were 20 states that fell between 0 and 5% of foreign-born residents. So I have circled them up here on my graph so you can see that, or my chart, there's all 20 there. So the frequency was 20 because 20 of the states fell in this interval, and that's 40% of our 50 states. Now, pause the video, see if you can fill in the rest of this table. Hopefully this is the table you were able to come up with. And notice, because each of my states appears once, I get this relative frequencies that add up to 100%. My frequencies add up to 50 because I have all 50 states. Same thing with my tallies. So if you want to make a histogram, whether it's a frequency histogram or a relative frequency histogram, you need to find the frequencies for the intervals you've chosen first. So here's where I have. Now I'm going to make two histograms. I'm going to make a frequency histogram and I'm going to make a relative frequency histogram. And I'm going to put them side by side so we can see the similarities and differences of them. So if I want to make these histograms, I'm going to have an X and a Y axis in both their cases. So I'm going to make just an X and a Y grid. The X-axis is going to be labeled the same for both of these. I'm going to label the intervals so they go up by 5s, and and that's going to represent the percentage of foreign-born residents in each state. So far, my two histograms, when I'm drawing them, look exactly the same. Now make sure when you're drawing your scale, it's evenly spaced. You can't skip over different areas just because you're not going to have data there. It needs to be consistent. You don't have to start at 0 like I did, but make sure you're consistent. What can be different is your y-axes. because one graph is going to be a frequency histogram for me, and the other is going to be a relative frequency histogram. So I'm going to label the one on the left as my frequency histogram, and since the largest frequency is 20, I'm still going to pick my y-axis to go up by 5s. So I'm going to go 5, 10, 15, 20. So 5, 10, 15, 20. And again, this is frequency or number of states if you want to put the context here. My other graph, I'm going to do percentages. Since the highest percentage is 40, I'm going to go up by 10s. And this is just an arbitrary choice that I'm making here. 10, 20, 30, 40, and I'm going to put percent as my label there. So right now, they don't look too different. What I do next is I want to make my bins or my bars, whatever you would like to call them. So since there was 20 states that fell into the 0 up to 5, but not including 5 bin, I'm going to have a bar that goes up to 20, and I'm just going to fill it in like that. The next one was 13, so I'm going to pick a bin that goes up to roughly 13 for the 5 to 10 category. Then we drop down to 9 for 10 to 15, so right around there. Then we go to exactly 5 to 2 and to 1. So this is roughly the histogram you end up with. And I can do the same thing for foreign-born residents. So I got my bin at 40. That goes up to 40 here. Then I'm going up to roughly 26. Then I'm going up to roughly 18. So 18 is going to be somewhere around here. I have 10. I have 4. So right around here, and then I have 2. And you're going to notice both these graphs look almost identical. And that is what it's supposed to have. If you have a frequency or a relative frequency histogram, they're going for a single data set. They will look the same as long as you've scaled them similarly. The main thing is I kept my x-axis exactly identical between the frequency and the relative frequency histogram. Now, I could have scaled my y-axis differently, so it might have looked like the bins were taller than another, but comparatively, they would be identical pictures. So if you want to describe the distribution, you could really look at either of these graphs to describe it. So if I want... So what they have in common is they have the same shape, they're going to have the same center, they're going to have a similar amount of variability, and they're going to have similar outliers. They're going to be exactly the same. If I want to describe this in words, I might say something along the lines of, write something along these lines. The distribution of percent of state residents that are foreign-born is skewed to the right, which we can see with a single peak somewhere between 0 and 4.9%. And we got no clear outliers here. So I've tackled shape and outliers and unusual features there. The center of the distribution is about the median, which is going to fall somewhere between 5 and 9.9%. You can roughly figure out what bin the median is going to fall in, although just from the histogram, you're not going to be able to figure out what that number is. And you can also say the distribution of the percent of foreign-born residents of the states varies from less than 5% to over 25%. So again, you can discuss how spread out the data is. I can't give you the exact range just from the histogram, though. So I might write some sort of discussion like this. Now, there are some positives and negatives to these histograms when you are making them. The positives, they are good for large data sets. We can have humongous data sets and they're good to visualize it. Whereas dot plots and stem plots weren't too good with big data sets. They're also good for comparing things as long as you pick the same scale. Now, if you're comparing two completely different groups of data, make sure you're comparing relative frequency histograms instead of just frequency histograms, because counts could be different, and that could make things misleading. Now, you always need to make sure your bins are equal length, and they should be touching as long as there's data within each bin. If there's no data within a bin, you just won't have a bin there. You can make your bins larger or smaller. If you make smaller bins, it's going to show a little bit more detail but less pattern. But you also don't want to make your bins too big that too much data falls into a couple bins and you don't get a good idea on what the spread looks like. But typically, it gives us a good idea on spread, shape, and center if we pick a good size for our bins when we make our histograms. So, I hope this video was helpful, and have an awesome day.